Hello, class. Today we're going to learn about the forces of flight and stability. Here are the 4 forces on an aircraft. Please do the best you can to draw an airplane and its force and its 4 force vectors. The first force vector we'll talk about is weight. The force of weight always points down towards the center of the Earth. All objects on Earth have a weight force pointing down. The second force we'll discuss is the force of lift. The force of lift is created by the shape of the wing on the aircraft and is always pointed up. The third force on the aircraft is the force of thrust. The force of thrust is created by the power plant, meaning the engine on the aircraft, and is always pointed forward. And the last force on the aircraft is drag, created by the air molecules in the atmosphere, and is always pointed in the opposite direction of its flight path or thrust. Alright, here's a quick physics lesson on force. But before we talk about force, you need to learn what is a vector. Well, I'll tell you. A vector has magnitude, which means amount or quantity, and direction. So again, a vector has magnitude and direction. The symbol used for vectors are arrows. The length of the arrow represents magnitude, so the shorter the arrow, the smaller its quantity or amount. The arrowhead represents direction, so wherever the arrowhead is pointing, that's the vector's direction. So since force is a vector, we can represent force by drawing arrows. The next lesson you need to learn is vector algebra. Luckily in this course, you'll deal with simple cases like the one below. Okay, here's a tough question. What force has a greater magnitude? Correct, force 1, because the length of the arrow is longer than force 2. Okay, let's see how you do with these 2 questions. What is the direction of force 1 and what is the direction of force 2? Yes, you're correct again. The arrowhead represents the direction of each force pointing towards. Okay, so let's say we know the amount of both forces. Force 1 is 75 newtons and force 2 is 40 newtons. In case you were wondering, the unit for force is newtons. Below, if the forces are applied in an object, what will happen? You got it. There will be a resultant force of 35 newtons pointing east because force 1 is bigger than force 2. So the box will move east. Here's a new problem. What is the resultant force if both force 1 and force 2 have the same value? Correct again. The resultant force, or net force, would be 0, and it's also known as static equilibrium. Now, you may not know this about the box. When the resultant force, or the net force, is 0, the box is either not moving, or it's moving at a constant velocity, meaning there's no acceleration. Let's think about this when you're in a car. If a car is moving at a constant velocity of, let's say, 35 miles per hour, you don't feel any forces. Thus, the resultant force is 0. However, if the car were to suddenly slam on its brake or on its gas pedal, the car would accelerate and you would feel the force from the car seat. Here's a simple example. Here's a simple example. What forces on the aircraft will be needed to move from position A to position B? Well, it has to be the force in the forward direction of movement. And that type of force on a plane is called thrust, which is generated by engines. Does thrust experience opposition? Yes, it does. That force is called drag. It opposes the forward-acting force of thrust, and it limits the forward speed of the aircraft. Here's a question for you. What occurs when thrust and drag are equal? Correct. The resultant force, or the net force, is 0, which means the plane is in equilibrium and is moving at a constant velocity, so the acceleration must be 0. But if you wanted to, how would you increase its acceleration? Well, there are a few options to this answer, or to this question. One is to increase the thrust, or instead, you could decrease the drag. Another option that may not have occurred to you is to decrease its mass. If you were to decrease the mass, the drag would stay the same because it depends on the plane's shape, but the thrust would increase because the plane is lighter. Okay, so what additional forces act on the aircraft? You're correct, the force of weight pointing downwards. They also forgot lift here. I don't see lift. Alright, so anyways, before flying an aircraft, knowing weight and balance is critical for safety. We already learned about the center of gravity, which is at a point on an object where you could balance it at one point, and the symbol we'll use for gravity is located at the upper right-hand corner. A reference point is similar to an origin on a graph. We call this origin or reference point datum, and it's always located right at the front of the aircraft's window. Now going back to weight, we need to worry about the weight of the aircraft, the pilot, the passengers, any cargo, and even fuel. So that's why you check in bags at an airport and you always see that they weigh it first, if you've noticed that. Now, before we put all these pieces together into determining whether or not it's safe to fly, we need a physics lesson on moment, or sometimes this is called torque. Moment is a very simple equation. You ready? It's force times the distance between the point of rotation and the force vector. But notice that the distance is perpendicular with the force vector and not at an angle. Another name often referred to for this distance is called moment arm. The name line of action is a line drawn along the force vector. Now from this slide, it's probably best if you write down the equation as seen below and also draw the picture. During class, we're going to go through this chart together. And also in class, we'll explain how to use this graph to determine whether or not it's safe according to how your weight is distributed in the aircraft.